Hi, I'm Shilpa Idnani, the Senior Educational Technologist at MIT X-Pro. Today we're going to be talking about the two-course online program, Machine Learning, Modeling, and Simulation, Engineering Problem Solving in the Age of AI. Data-driven methods and machine learning are transforming the way engineers and scientists like you approach modeling and simulation. But if you haven't had much experience in data science or in modern computational methods, you might be questioning what's behind these buzzwords. In Course 1, we drill down into the basics of simulation and machine learning and explore the specific techniques. They run the gamut from merely simulating a scientific problem or system using ordinary differential equations and the Forward-Euler method, to filling in the gaps in computational models and making determinations of systems that might have particularly extreme risks out at the tail ends of a bell curve. Many machine learning courses out there focus on how these new tools can help predict consumer behavior, analyze human preferences, or model huge repositories of text, speech, or images. In this program, we aim to peer under the hood and really demystify machine learning for applications outside the typical marketing or sales frameworks. In Machine Learning, Modeling, and Simulation, we explore the usage of machine learning as a tool of innovation and scientific exploration. What do we need to do to predict the life of a lithium-ion battery? Can we image the subsurface of the Earth and map the tomography even though we have a limited set of data receivers? Can we quantify the risk of an extreme engineering or natural event and explain the properties of such an event? MIT X-Pro programs like this one use cutting-edge research in the neuroscience of learning. The courses follow MIT's motto, Mens et Manus, Minds and Hands, and feature hands-on activities and real-world applications that are fundamental for acquiring significant learning. In Course 1, each model and concept we teach is associated with an interactive simulation assessment, where learners can explore various key variables and algorithms in order to figure out the solution to the problem or issue presented. In Course 2, you will be presented with a number of applications of these concepts across STEM, as presented by a wide variety of MIT faculty. Topics include determining the value of an oil or gas lease, and creating new materials for uses in various applications. This program is comprised of two 5-week courses, and the content is broken into 5 categories. Explore. You'll learn core concepts through engaging videos and research-based readings. Practice. Through multiple choice questions, scenarios, and simulation activities, you will practice concepts without an impact to your grade. Apply. Via case studies, you will apply conceptual material to solve problems and take stocks in how principles apply. Share. Through peer-to-peer discussions, surveys, and polls, you will reflect on what you've learned and comment on your peers' experiences and insights. Assess. Using graded assignments, you will be evaluated on your understanding of the material and your ability to apply it to the workplace. There is no application process to enroll in this program. As the program was designed for working professionals, we do recommend you have a bachelor's degree in engineering or the physical sciences and have proficient knowledge of college-level mathematics, including differential calculus, linear algebra, and statistics. Programming experience is not necessary, but knowledge of MATLAB or previous experience is useful. Once you complete the 2 courses in the program, you will be granted a program certificate from MIT X-Pro and awarded 5 continuing education units. But most importantly, you'll understand the physics-based models, computational science, and engineering paradigms upon which machine learning solutions are built and therefore leverage the competitive advantage of big data for your organization.